We will quickly move on to the next technical session. There will be...
Before we start the next technical paper presentation, we would like to introduce you to some rules. The time allotted per presentation would be 5 minutes, and I would request Shri Ashwini Kumar, ex-CEO Rourkela Steel Plant Sale, to chair this session as chairman, and I request Shri Anup Datta, Chief General Manager, Central Plant Vizagsteel Plant, to play the role of rapporteur. I now invite one by one our subject matter experts and the presenters to please take their seats on the dais. Mr. Brajesh Nahar, COO, APL Apollo Building Products Private Limited. Mr. A.V. Bhushan, Director R&D Innovation Habitat Energy Co. Limited. Mr. Badal Balchandani, Assistant Vice President Sustainability, GSW Steel Limited. Mr. Kaustubh Ganguly, Assistant Vice President Technical Sales, and Mr. Saugat Das, General Manager Technical Proposal, Prime Metal Technologies India. Mr. Nishant Juhair, Assistant General Manager Sales, Denali India. And Mr. Abhinav Prasoon, SMS India Private Limited. We now hand over the proceedings of the technical paper presentation to CGI Central Plant, Shri Anup Datta.
Very good afternoon to all of you, and very warm welcome to all the presenters in this first technical session. I won't take much of time. Straight away we'll start with the invitation to the presenters, and I'll request them, as because they have to finish in 5 minutes, so they will give their introduction briefly while they are giving their presentation. So the first presenter, Nice Soch with Next Gen Steel Building Solution, Build Better, Build Faster. It's from Brajesh Nahar, CEO, APL Apollo Building Product Private Limited. Yes, sir, please.
I will start directly because the original time allotted to me, it was 15 plus minutes, whereas now the new target it has been given is 5 minutes. So I'll try that I should complete in 5 minutes. I am Brajesh Nahar and I am Chief Operating Officer in APL Apollo. You can see the motto which is there for the company is the Nice Soch for the next generation steel solution, building steel solutions, a revolution in the construction industry. You can see that the structure, it is purely made up out of the tubular product only. Very less concrete it has been utilized. I was a part of National Steel Policy 2017 at New Delhi, wherein it was envisaged that India is going to attain almost 300 million ton of steel by the end of 2030. That time in 2017 it seems to be difficult, but now with the increased capacity it seems that yes, we will be able to achieve that target. But the next question it has come, because that was not envisaged, that the moment we are going for more and more steel means more and more of infrastructure development it will be there, so more and more of carbon emission it will be there. So now the next biggest problem it has come to us is the decarbonization or reduction in the carbon footprint. In APL Apollo, we believe that I will just touch upon some of the statistics which are there, which are helping in the infrastructure development that is related with the economy. Economy is there because almost they have given the target of almost the 6 to 7% for India for the next decade. In IT sector, in the infrastructure sector, you see population 1.5, which is going to be the biggest asset for us, and we have already become the fifth fastest growing economy in the world. Whereas if you see the AI sector, 59% of the organization is going to utilize in the AI, artificial intelligence, basically for the R&D and reskilling of the manpower by the end of this decade. 24% of global workforce, I am talking about global workforce, is going to be from India. That shows that importance of Indian labor for international market. And if you see the 45% of Indian growth, export as well as GDP, it is going to come from the small scale and micro and the small scale industries. And if you see 54% of the people in India, they are utilizing the internet. That is the good sign, and it is going to give us a big boost in the total economy. If you see the APL Apollo, it has got almost a decade. The legacy of excellence, it is there. It is working as a global leader for the structural steel tube, and you can see the innovative capacity. Every time we are looking into the future and then going for the thing which can give us the competitive edge over the people. Hence, we are finding many of the technology, say direct forming technology for manufacturing the structure that is there in APL Apollo. Then expensive the product portfolio. In APL Apollo, we have got almost 2,000 SKU plus products are there, ranging from small tube to the structural hollow section up to the 500 and 500 which is there, and now we are going to commission 1000 into 1000 into 40 mm bigger pipe for the construction industry. Then we have got the robust distribution center, almost more than 1100 distribution centers in India is there, hence where our accessibility to the market is very good. And we are driving the total transformation in trade practices, commitment to innovation, it is there. We have got the capacity of 3.6 million ton of steel every year we are processing. 30 countries and around we have got the presence, and 11 manufacturing unit all over India is there. We strongly believe in the decarbonization, sustainability and the infrastructure development. There are few awards which are there for the sustainability, which is the main topic there in front of us. Then what matters in today's construction industry is the speed, quality, cost and environment and the technology. That is where the APL Apollo comes into, with the logo of Nayi Soch, with the next generation steel solution for the building, build better, build faster. Then I did discuss about the APL Apollo. Then this is the journey of APL Apollo. We started in 1986 and in 2023 we have established the Raipur unit, which is there, 600-acre land is there, and there are many more innovative building solutions are there. You can see in the slide that we are first to introduce many things in India. That is there in this presentation. I can share with you. You can see, but there are many things. We have got that 500, that is the biggest, 1000, this is the biggest in India as well as second in the global, which we are going to manufacture after some time. And then you can see that manufacturing, how we are making and then converting into the complete structure like hospital and other. These are the few structures are there. You can see the application of tubular product for the various things. Then we have started with the flat product also, and we are manufacturing the sheets, coated sheets. Then this is a very innovative concept we will be bringing, that is the color coated purlin, which is utilized for the construction industry. So we have got the unit for making that color coated sheet up to 3 mm. You can see the design topic, that is the decarbonization and steel buildings. You can see there are many advantages are there when you are going for the tubular product as against the concrete structure. So it is the research is indicating that reinforced concrete with the steel structure is saving in most of the cases almost 60% of the emission. This is the age-old technology versus the tubular product which we have introduced now, and we are going very fast way. You can see many benefits are there in the tubular versus the conventional RCC structure, and this is also there with the, you can see the age-old technology, the build-up technology, where the steel structure.
One more minute left.
Okay. Steel structure along with the concrete, whereas now the new concept is there to build the steel structure purely based on the making the structure based on the steel only. These are the few of the things which can prove case studies there that we can reduce almost 20% of the weight if we are utilizing only steel structure for making the industrial shed. These are the few approvals are there where we are selling our product to. These are the government agencies are there. Then manufacturing plant is there in Raipur. So you can see there are many first against the name of Raipur. The capacity is almost 1 million ton still is there, whereas in 44,000 we are making the plate product, whereas the 41,000 we are making the tubular product. So the combined together is 1 million ton of steel which we have got at the this thing. This is the new product we have launched recently. Then these are the branded product which are there in our list which we are selling, and these are the brand ambassadors are there. So you can see the Amitabh Bachchan and the Akshay Kumar, they are there and helping us to sell our product in the market. These are our products.
May I now request you to, because we have increased the time to 8 minutes, but still.
Okay. So what? Thank you very much for giving me the time. Though the time it was less, but still I tried to tell about the things which we are doing for the carbon. At last only I will tell you the things which we are doing for the carbon emissions. These are the structures are there. Yeah. These are the way forward which we are doing it. You can see from this thing. Thank you.
Thank you, Mr. Nahar. I understand the time was a little bit too short, although we tried to increase it up to 8 minutes. And I'll humbly request all the other participants to kindly continue, but they should summarize their presentation in 8 minutes only. And the next presenter is from Avitech Energy Con Limited, Mr. A.V. Bhushan. Again, Mr. Bhushan, you are requested to minimize your introduction and finish it in 8 minutes time.
Sure, sir. Sure.
We are not taking any questions, but any question if you do have, then you can give in writing and we'll see that you get the answers of it. Thank you.
Yeah, good afternoon everyone. I guess all of you must be hungry and so am I. So I will keep it very short and brief. We are from Avitech Energy Con Limited and we have got a number of technologies and solutions for capex-free initiatives for decarbonization. So I shall go a little fast and I will. So just to give you the context, the steel production, of course, all of you know accounts for a huge amount of emissions, right? And the Indian steel emission intensity is about 2 to 2.2 tons of carbon dioxide emission per ton of crude steel. And this needs to be brought down to 1.85, which is as per international standards. So what happens is, in one of the important factors to be considered is the emissions impact of energy efficiency and resource efficiency. When we talk about new technologies of CCUS, green hydrogen, one of the points is if you use your energy and material resources very efficiently, it can make a huge impact and dent on your CO2 emissions. And this study also pointed out, it's an international energy agency study, which pointed out that 38% impact can be made on just utilizing your material resources and energy resources very efficiently. So with this as a context and a background, we at Avitech have developed capex-free technology solutions and products for better resource efficiency and contribute towards decarbonization. What do I mean by that? I will just explain to you about some of our products. So the first category of products, okay, the brief objective of some of the products that we have, technologies that we have developed, is reduction in specific energy consumption, improved process efficiency, which of course results in greener environment by CO2 reduction. So the first product that I will introduce to you about is a flow rate for ores and coal, which is basically something like a super absorbent polymer. As you know, typically in monsoon season, you get very wet coal and wet ores, and therefore the flowability of these products is very hampered, and it affects the production. Consequently, there is a production loss. So we have come up with a product to elevate these problems. I am not getting into the technical details. Similarly, we have an organic binder which we have developed for agglomeration. This is for the pelletization and agglomeration process. So what we are focusing on is all improvement in process efficiencies. This reduces bentonite consumption by 30 to 50% and also improves the quality of the pellet. Then we have come up with 2 products related to coke oven, and one of them is called Thermac MT. This is typically recommended for all types of coking coal, and wherein it improves the quality of the coke produced and also giving associated benefits. Similarly, we have a product for coke moisture, reducing the coke moisture. Yeah, this product is called Satmac. As many of you would be from the coke oven process would at least know that the moisture of the coke post wet quenching is around 5 to 6% or 4 to 6%. Any reduction in coke moisture can result in a significant reduction in energy consumption in the blast furnace, which reduces of course what is called the coke rate in the blast furnace. So we can reduce this by almost 20 to 30% moisture of the coke post wet quenching. So you can see a wet coke, it goes used by Satmac, and then you produce dry coke with a significant reduction in moisture. We have come up with a product for sintering, and this improves the boiling index and reduces sinter fines. One of the biggest issues faced in the sinter plant is reduction of sinter fines. So we have developed a product which reduces sinter fines very significantly, and we are working with various companies for that. So if you really see a combination of 3 products, Thermac MT, Satmac and Syncat, can almost reduce your coke rate by 20 kg per ton of hot metal, which is very significant by any standard. And this obviously results in close to 60 kg of CO2 per ton of hot metal reduction. So these are just process efficiency improvements without incurring any capex. So these are some of the sustainable decarbonization initiatives. I will not get into each of the products, it's very long. I would invite all of you to visit our stall here, stall number 6 and 7, and get into the more details. So some of the products which will lead to using our products, we can almost reduce 1.7 million tons of CO2 emissions for SAIL alone, assuming a SAIL production of 20 million tons. So we are also working on new verticals. We have developed this artificial intelligence. It's a digital twin for met coke process, wherein we want to optimize your blend and reduce your overall blend cost. So we have developed a digital twin for that, and we will be happy to share details with you. Similarly, we are working on waste recovery from steel plants, metal steel waste from steel plants and DRI plants, which we want to convert them into circular economy, into briquettes, and make them reusable for DRI furnaces or steel wherever possible, based on the raw mix and briquette characteristics. So these are some of the initiatives. We are also working on CO2 capture by itself. This would be of course a capex solution, wherein what we are doing is, as many of you would know, that carbon dioxide solubility in water is very poor. So we have developed a catalyst which enhances the solubility by almost 1000 times, and therefore we are simply capturing CO2 in an aqueous medium, and then this medium can be discharged or it can be used to generate byproducts. So these are some of our lab scale reactor for the CCU technology, and you can see we have achieved very good reductions in SOx and CO2 also. We have our own pilot oven. This is our R&D facility, which have a pilot oven and CSR and CRM equipment, and of course disc pelletizer for agglomeration, R&D lab, a very state-of-the-art R&D lab in Mumbai. So we have, our strengths are an excellent dosing system that we have developed, in-house R&D in association with world-class domain experts in material science and metallurgical process. We provide on-site technical systems. So basically our aim is to develop capex-free products and solutions to improve your process efficiency and make an impact on CO2 reductions. We look forward to working with you towards the decarbonization. Thank you.
Thank you, Mr. Bhushan. Very interesting presentation. I think there were so many things related to our steel plant which we can use in coming times. And definitely I think there must be many questions in the mind of many people. But of course, because of paucity of time, I think we can have a discussion over lunch. While we are having lunch, we can have discussions over these matters.
Sure.
And if at all anybody is having any question, please give in writing and we'll try to get you the answers. Thank you. Thank you, Mr. Bhushan.
Thank you.
And for the third presentation, I would like to invite Mr. Badal Balchandani from JSW Steel, decarbonization of steel industry. AVP Sustainability, Mr. Badal Balchandani is from AVP Sustainability, JSW Steel Limited. Yes, please.
Thank you, sir. A quick introduction. I am Badal Balchandani from JSW Group, and I thank all the organizers to give me a chance and present a couple of minutes on what JSW is doing as well as the significance of decarbonization in the industry. So just to set the context, what is happening in the global risk landscape, the World Economic Forum has pointed out for short, medium term and the long term effects of risks which are going to be faced. And what we are trying to show, there is a transition in the green color from 2025 to 2033. The green color represents environment. What we are trying to say here is that the environmental risks are going to be increasing day to day. As recent as till yesterday, we are seeing erratic rainfalls in Gujarat and causing floods. So climate change, of course, we know it's going to be one of the most important aspects to be addressed, and this is what the World Economic Forum is also trying to project. Talking about sustainability is now into a must-do thing, and it has strong profits or benefits which causes to the organization. A lot of customer demand because of process and energy efficiencies are kicking, the profitability is increasing. There is a lot of risk management frameworks which are being caused and helping because of sustainable practices. There are a lot of sustainability linked instruments like sustainability linked bonds or loans at a lower interest which the organization can incorporate, which helps in incorporating sustainability and running the business in a better way. We all know about decarbonization of steel. We have a lot of speakers speaking about this, so let us move ahead. And this is a graph which shows where we are presently standing in terms of production, where we want to achieve 2030 to close to 300 million tons and about 500 million tons by 2050, and India is going to be a significant contributor. So it's an apt time we all act to decarbonize the steel industry. There are 4 simple incremental levers which we need to incorporate, showing a transition pathway, which is recycling. We have had speakers talking about increasing the scrap usage into operations. Today at JSW as well as other steel companies, we are utilizing about 10%, and we aspire to go to about 20% in near term, depending upon the availability of scrap, which is a concern. Efficiencies, process and material efficiencies is one of the core levers till 2030 to be deployed. Renewable energy is going to be costly, but yes, we need to embark, giving about 10 to 15% direct reduction in CO2 emissions and usage of cleaner fuels. 2 more technologies, we have all been speaking about hydrogen and CCUS. These are the technologies which are going to be kicking in post 2030 onwards, and today we are seeing development on pilot scales, but these are the breakthrough technologies which are going to be helping to decarbonize the industry in the future. How JSW is responding, we have a big framework which has been accepted and being spoken by our chairman, which shows our commitment to decarbonize. We have a lot of commitments which have been made in terms of climate, energy, resource efficiency, water, waste and emissions. Climate change, we have taken aggressive targets to become net neutral in all our operations by 2050, and we have chalked up our plans. The plans are medium-term targets for 2030 and long-term targets of 2030. What we see here is the levers which we are going to deploy, naming process efficiency, renewable energy, implementation, alternative clean fuels in the short and medium terms. While in the long terms, there are technologies, we are working with significant partners for top gas recovery, circulations. We are working on pilots for hydrogen, we are working on pilots for CCUS, and also not less, we are also working on probably talking about electrolysis of direct electrolysis of iron ore. We have launched a program which is known as SEED, Sustainable Energy, Environment and Decarbonization, for improvising the process and material efficiencies. As one of the speakers was telling, that is the main arena for 2030. And what we have envisaged that by doing that, there is a possibility to reduce 18 million tons of CO2 by 2030, which is as good as what Sri Lanka today emits, or equivalent to 3.5 million cars on road. We have a small CCU plant at one of our works as a pilot project which we have done, and we are running from a long time. We want to see that we can scale up and use it in our blast furnaces eventually to capture the carbon capture and see the utilization forward. Renewable energy is aiding this. We have our sister concern JSW Energy, and it is going big time into implementation of renewable energy businesses. And we have also implemented a small 25 megawatt electrolyzers for producing green hydrogen, which will be commissioned by FY25, which will be used in steel making. So we are looking at breakthrough technologies also and trying out our best to decarbonize and see our efforts towards moving our targets. These are some of the initiatives like SEED program, as I already said, renewable energies under implementation on a big scale. We have ventured into electric mobility by having a stake in MG Motors, and we are driving electric mobility into transportation, and we are going big time into utilizing and going towards circular carbon economy also. Our targeted approach is for mitigating potential risks and creating opportunities in the open markets today. We have done a lot of implementing initiatives across our value chain, right from mining to the product, which can be evaluated, but in the paucity of time I will not go deep into this. And we have paying a lot of attention to making low carbon steel at this point of time, going to greener steel in future. There are many awards and international certifications which we have. We have EPD for all our products, and we have got a Green Pro certification for our TMT bars too. Last but not the least, when we are acting towards decarbonization, our efforts in the global arena is being recognized, and the slide shows some of our accolades which we have achieved, and we are proud of that. We are moving in the right direction. We urge the overall steel industry to move towards decarbonization and increase their efforts and make our world greener, better place to live for all. With this, thank you to all.
Thank you, Mr. Balchandani. Thank you very much for taking us to a tour of various initiatives which JSW is taking in its plant. I am very sure you must be having so many questions, but sorry again to say that we can have these questions while we are having lunch. And for the next presentation, I would like to invite Mr. Kaustav Ganguly, EHRC, a game changer, product in steel flat products. Mr. Kaustav Ganguly, please. You can give your introduction.
Okay, I think time is short, no introduction, jump on to the subject. I will be presenting here the EHRC along with my colleague, Solvato. So Solvato, please come on the stage. And can I have another mouth? Okay, or we can use it. Okay, thank you. Okay, so we'll use this. Okay, we are in the prime metals, we are for prime metals. We will be taking you through next generation hot rolled coil. We are talking about the steel, the end product is either flat or long in general. So, and specifically we are talking about the hot rolled coil. And in a hot rolled coil, there has been a conventional process. If you think that it is cast, then it is cooled, then it is reheated, then once again taken in the mill for the rolling. And this has been followed for the generations. And since late 90s, people started to thought of this carbon emissions, energy saving, all these things. So things that casting came into the place. And everybody now aware of this, that previously it used to be the range of the 250 or more than that thickness casting, then further rolling in the two steps, the wrapping and the finishing. Now it has come down further. The casting is taking place in a much thinner stage. So in general, the approach of every company, it will be different. So we will advocate, or we will say promote, the endless rolling, specifically for the hot rolled coil, where we will be showing you slowly that casting will start in one end, and till the time the coiling will onboard. And in this process, you will not only save the energy, but geometrically you can produce something better way, and mechanically you can produce something in a uniform way. So we will go through those things together. Okay. So Gato, just show that. And before you start, one thing, it's not, as of now, it's not a replacement of the hot strip mill. Hot strip mill is there, it will be there. We can produce certain products in a better way, smarter way, metallurgically, in a good tolerance and economically favor. And most important, we have been talking and discussing for the CO2 emission, saving our environment. These can really give a good impact on our environment service. So Gato.
Yeah, thank you, Kaustav. So without wasting the time. So I had, you know, seeing the dais, it has been quietly designed just like our ESP, the 8 stands, 8 people. So it's very nice, and the time which we take normally from the liquid steel to the HRC is 5 minutes. So it's quite you know, a realistic one. So let me go through. Yeah. So let me take you through the, you know, the layout. So it's basically the vertical calf caster we have. So it's a very fast caster. So just like the normal conventional caster, designed to the patented design, and then it is directly coupled with the high reduction mill, which is the we tell is the normally the roughing mill in terms of the hot strip mill. And then you can already see that we have this inductive heater, so which is basically we control the heating of the edges and also the center to this transversal induction heater, which is very much required for the heating of the strip. Then it goes into the finishing stand, which is a 5 stand. Normally, this line is designed with a standard ESP, and then it comes into the cooling area, which is lamellar cooling, and it comes down the high speed shear, which is normally known as a down coiler. So the important part of the story, which Costa was telling, we don't have any reheating furnace, and it is directly coupled with the.
Okay, now coming to quickly on what is the difference. In a conventional hot mill, you have a storage slag, then you have to reheat. So here we are utilizing the internal energy, which is the head of the caster. Directly it is coming to the roughing mill. Okay. Now I would like to highlight you here the orange part, where you can see the outer temperature is 1050 and inner core is high. Now what is the benefit out of this? Basically you are utilizing the heat what you are getting from the caster directly for the roughing mill. So the power savings you are having. Now after that we are calling it two-step rolling. Two-step rolling means you are just utilizing the heat of the caster or roughing stand. Then you have a possibility of further heating or cooling before the finishing mill. And in general, when we are rolling in this mode, after the roughing mill, we are getting, for the thinner gauge, you are getting at least 8 to 10 millimeter thickness of the strip. And then it is passing to the finishing, and then we are coiling. So the inverse temperature is the better utilization of the energy for the product. And when you are having the inverse temperature, when you are having reduction, that is throughout the volume you are getting the transformations. So whatever the product you are having, not only the surface, it is basically reducing and changing anything from the throughout the cross section. This is the beauty of this product. And we are going for a continuous mode. Since we are going for a continuous mode, so this is the only hot strip mill which is producing below 1 mm thickness HR coil in a stable production commercially.
Yeah, another point which I want to add with Costa, which is a very nice one. So since we have this transversal heating system, it just moves when the strip comes, because the homogeneity has to be maintained. So it automatically moves. So it's a very stable process we have. And you can see the length of the line is around about 180. And since it is a stable process, we can guarantee uniform mechanical properties, and you can tune into the proper geometrical tolerances. So what it brings into, so you can see our customers like Rizal and Arvedi have been promoting like thin gauges and hot strip mill in a separate way, because they are getting a huge amount of the market. You know what Costa was telling, from 0.6 to 0.8 to 6 millimeter, they are using this market for the ESP product. So this is a new product which we tell it is an established product in the market, and people are using this product as a substitute of the direct application. Why it is?
So quickly going through the core message. Since there is no head and there is no tail, So you are basically utilizing the full coil. Even in any patch mode, the head and tail cannot match the property because it is not in tension. Here, once you start the process for 3000 ton, mill will not see any difference. So, whether it is head or end or the body, you are having the uniform yield strength, you are having the uniform grain structure, and also the, specifically if you look at the geometrical tolerance. Okay, you are getting a stable product, so each and every product is a prime, whether it is end or end.
Correct. And we don't exaggerate because you see the cobalt rates are very, very minimal. It's practically to zero. So and we produce in there is no inhomogeneity of the production of the coils.
So just to give you an idea, this is the product on the shape we are talking about. The outer line, the red one, is the geometrical tolerance, what is achieved and what is accepted for the hot roll coil. And the green part or the yellow part, we are talking about the after cold rolling, what kind of geometrical tolerance is acceptable. Now in this case, even in a hot mill, you are getting a product which is giving you a tolerance or the accuracy geometrically, which is achievable after cold rolling for the automotive grades. Okay, so you can see where we are coming down and we can replace lot of cold roll products, and we can replace lot of direct application, means quickly that several products can be produced in a hot mode which can substitute the cold roll. So it's a saving in time, saving in money, saving in alloy, saving in environment. Okay. Okay, so the message what finally would like to give in a short time, this is something globally accepting and people have produced already more than 100 million. So two-step rolling is giving you geometrical tolerance, and the continuous mode gives you the better yield, and since you don't have the reheating, there is no scale loss. So product wise, environment wise, few things, yes, you can contribute to the, environment also. So it is the next generation product. The name we have not given, it is given by our customers, and they are happy, they are using this endless mode. So this will be the future for certain grades, and this is, as we have started, this is not everything we can do, but few of the things we can do which has a certain volume of the market, and we hope we soon have something in India significant.
Yeah, before we end up, one of the important topics was the carbon neutral, and this is the only product in the market which is a carbon neutral product.
So the only product which has achieved, we are discussing a lot of things, the carbon neutral. RVD BSP is the only mill which is producing zero carbon hot rolled coil. Thank you. With this, we can conclude and we are available for the questions.
Thank you, Mr. Ganguly, and thank you, Mr. Das. It's been an interesting presentation. Of course, there are many more other things to be discussed, but we have to cut it short. Sorry about that. And let's move to the next presentation straight away. It's from Danelli. Mr. Nishant Johar, I'll request to kindly come to the dais, and Danelli's state-of-the-art rail and section mill technology. Mr. Nishant Johar. Again.
So good afternoon everyone. My name is Nishant Johar, and today it's my pleasure to introduce the technologies which Danelli has to offer regarding the rail and section mill market. In the forthcoming slides, you will see a combination what happens when Italian DNA of customization meets Indian DNA of mega science. Before moving ahead, let's have a look at the video. It's a short one. Okay, I think we have some issues with the audio. We'll move ahead. So moving ahead, during the course of this presentation, we would like to see where we stand as in India when we talk about the overall challenges and need in the rail and section mill market. As you can see, why rail is preferred as a preferred mode of transport is because it is the least carbon dioxide emitting mode of transport. So till date and in the coming future, this is the most preferred mode of transport. Talking about India, India is going big now. with the help of and sincere comments of Ministry of Railways and the Government of India, we are eyeing at some big projects. If you look at the slides here, we talk about high-speed rails tracks, which we designed for more than 300 kilometers per hour. We are talking about semi-high-speed rails, where we are talking about laying new tracks and revamping some existing tracks. With it, we have the freight corridors, which are open. And also, we have a lot of metro projects which are going on. We are estimating combined, let me say, demand of around 5.4 million tons of rails in the coming future. Now, to serve this, why then is the right partner for you? Looking at the rail trends, if you see, we require two kind of key requirements which are there in the rail market. One is for the high-speed railways, which require longer rails with tight geometrical tolerances in order to have a smooth ride experience. On the other hand, we have heavy haul lines which are designed to carry heavy axle loads. So this what it requires. This requires more wear resistance of the rail. For this, we have the Denali RS2 system, which we call as Denali head hardening system. If you look at this interesting graph, here you can see two axes. One will show you the radius of curvature, and the other you can see the axle load on the tracks, which is per year. If you see the two important components, the places where we have tight radiuses, there the wear is much. So this is the demand of, for example, metro projects. And now India is slowly advancing because the new rail tracks will be in a range of 1750 meters of radius and around 35 metric tons of axle load. And you see the demand in the coming future is going to be R350 HD when we call about heat-treated rails. Nowadays, since we have a more, let me say, straight-lined rail tracks, so the demand is more towards R260. But in the coming future, R350 HD is the future to go. So as you can see, by having RS2 system compared to the existing systems we have in the market, we have up to 3 times of wear savings and up to 2 times of roll contact fatigue savings. This is a typical example what happens when a track of an axle capacity of 16 million tons per year undergoes repeated load till 3 years. And the picture you saw before was the condition, the deterioration which happens after 3 years. Instead, Denali head hardened rails will give you the same result, a better rail even after 5 years of operation. These are some of the significant benefits we have in our system. Of course, its operating cost wise, it's very low, approximately 1/3 compared to the air blow system. Then we have uniform cooling because in this system, what we are doing is we are taking the entire length of the rail and we are dipping it together in a water polymer bath. Then, of course, the cooling rate flexibility. Because of the deep penetration, we are able to also get results up to 13 degrees per second. Then, one important point is we are able to decrease the dependency of the alloying elements, where we are saving for 350 HD, we are saving around 0.1% of chromium. Then again, there are process stability, consistency. We don't require any additional heating equipments also for a head hardening system. Then, of course, we have the reduced installed power. We have some reduced maintenances and a shorter commissioning time. This we will go ahead when we see our client testimonials. So, looking if we compare the RS2 system with the spray technology, we see that not only on the head, which has the prime impact of the wear, but also all throughout the length from 2 mm from the surface till 40 mm till the surface, we have a consistent value of hardness, which is a key requirement when we talk about the new generation of rails. Let's move on to the section market. Now, with changing times, only there are extreme engineering realizations which are happening, and this is calling for some new things. For example, we need optimized solutions. We need the economy of fabrication is very important. For example, the cost of welding for the end user. The speed of erection is very important. Seismic design, fire resistance, and all this is leading us to evaluate the products under a sustainable point of view. For this, Denali has in the catalogue 2 inline treatments for rails, which is known as QST and ACCP, meaning quenching and self-tempering of bars, as well as accelerated cooling. So this system is designed basically to, this is the key slide for this. For example, let us take an example. A conventional W beam of 360 by 744. What we did, we replaced this, we decreased the web, and we try to have the same result after treating it with the QSC system. And what we see that, of course, since the web is smaller, the weight goes down. By how much? It's around 20%. Then, due to this weight reduction, another advantage we get is in the material cost. So we have a cost saving because lesser amount of ton can do the same job compared to the conventional material. Another thing is, since the thickness of the flange and web are smaller, it takes less investment also in terms of the welding of the material. This is a quick video about the quick quenching and self-tempering, wherein we take the material at 850 degrees and eventually get it at 600 degrees at the outlet after quenching. So then I'll be moving on. We have all kind of systems which are able to cater all kind of ranges for the bars. These are some of the equipment, auxiliary equipment which we offer for the rail and section mills. I'll be quickly skipping this also. Now this is important. We would like to highlight some of the achievements. Why we are here in front of you asking to acknowledge at least the new head hardening system of rails. This is because of our client database. Recently speaking, as you can see, we have a lot of references where the first graph you can see denotes the type of products, the type of profiles.
Please sum up quickly, Mr. Nishant. Sum up quickly.
Okay, so I'll take you to the vizagsteel. Vizagsteel, basically in 5 months we were able to achieve from 0 to 110,000 tons of rolling. When we talk about Mechel, which is our rail plant, you can see extremely tight tolerances after the installation of our mill. Similar we did in steel dynamics, where we worked on a non-denial mill and we were able to increase the productivity by 30%. Emirate Steel, again I heard this name before during the course of the day, and here also you can see how efficiently we manage the tolerances. ArcelorMittal, the Fadanch, where we revamped the mill, also you can see a faster learning curve. In ArcelorMittal Poland, they are using our technology, rate hardening technology, and in this year they will be producing R350 HT rails. Emirate Steel, in Emirate Steel we produced first time in the world a Z profile which was done with 1 medium and 3 stands in just 8 passes. Also the mill was designed for 630 profile, the sheet pile, but now without any problem they are rolling 700. The conclusions. The conclusion is that basically this is the reason we stand before you, to trust and provide chance to players like Delhi who are always focused on the emissions and the infrastructure development in India. Thank you so much for your time.
Thank you, Mr. Nishant. It's been a very, very informative and interesting topic, especially for Reliance, and I am very sure many people will be waiting for you during lunch session. They can have their questions. And for the last presentation, I'll be inviting Mr. Avinav Prashon from SMS Group, significance and role of decarbonizing the iron blast furnace. Being an old blast furnace man myself, I am very eager to look at your presentation and learn something from it. And I'll request you also to limit your presentation to 8 minutes.
Good afternoon, everyone. So everyone is hungry and I will try to complete before the buildings. So, 3 plants at our group. So we have 150 years of experience in iron making, in fact steel making. So we are one of the leading suppliers of technology and equipment for the entire metallurgical value chain. Our mission is to turn the metal green, and the main levers for this we believe decarbonization of metal process, the optimization of the process, power to X hydrogen, life cycle partnership and digitalization, and circular economy. So I think most of the people have already spoken on all this matter. I will just move ahead. And again, we provide solutions, wide-ranging portfolio. I will just go to the main topic. So yeah, why decarbonization? So this is Keeling curve. So this has been monitoring the CO2 levels from 1958, and you can clearly see there has been a rise. So like 1958 it was 315, and now we are around 420, 425 ppm. So it is true, and we are also experiencing the effects today in the world in while record temperatures, extreme weather events happening everywhere in the world. I will not take much time on this because most of the people have already spoken on this. But what I would like to emphasize, even with all the measures, we can see by 2050, around 60% of production will still be through the primary route. We can see a good increase in the secondary route, which will definitely help in decarbonization. But the fact is that blast furnace is going to remain, and it will have an impact on our processes. Specific to Indian scenario, again here, our estimates say that the production of through blast furnace will be almost double by 2030-35. Again, there is increase in EF, DRI based routes, but still, to support our production, to support our growth, we cannot move away from blast furnace, and we will explain why we cannot move away from blast furnace. And then comes decarbonization of blast furnace, because since we have to live with blast furnace, it is important that we decarbonize our furnaces. As per the energy agencies, we have to decrease around 50% of emissions through the blast furnace by 2050. So what are the challenges for our green steel? First, the iron ore and pellet availability. So we all know with time there will be limited availability of high grade good pellets, and there will be high premium on that. So we need flexible ore solutions. Availability of scrap, this has already been spoken in this forum, so we will not go into details. Green electricity availability. So again, unequal availability of sun, wind and free usable land, which in turn is high, will increase the cost of hydrogen, green electricity, scope 2 emissions in some regions. Hydrogen availability. Unequal green hydrogen production cost. So this also we have already spoken in this forum, that the cost of hydrogen does not support us in a sustainable production, at least in the near future. So why integrated blast furnace making? Blast furnace provides us a route which has a flexible ore usage. Centrofines, we were always speaking of circular economy. So unless we have centrofines, center is one place where we can use, which helps us to maintain the circularity in our system. So all the waste material which is generated in the steel plant is routed through center plant and can be easily consumed by blast furnace, which is in future also required. It can use lump ore, it can use HBI, and which allows us for cost control. It is a proven iron making method, and it is a method which provides a high quality of hot metal for the production of high quality of steel. So certain other routes like DRI, AF and all, there are constraints when it comes to quality steel. It provides a high autonomy in terms of the fuel usage. It can use BFG, COG, internal powers, then global sourceable energies like coal, ammonia, which again gives us a good control on the cost. Energy flexibility. Again, blast furnace is one place which can use variety of energy sources like coal, coke, natural gas, biomass, hydrogen, ammonia, and there are many more in future. So for these reasons, BFG route is going to play a critical role in the future also. So we will propose a few solutions to decarbonize blast furnace. First, we will propose coke oven gas injection. See, evaluation of existing process is the key for achieving our short and medium term goals while preserving existing investment. And for this reason, we propose coke oven injections because it does not disturb your existing setup and can be installed in your existing plants, further decreasing the CO2 emissions. It is just a layout of consumers in a conventional steel plant. So as we can see, most of the carbon monoxide COG gas is used in reheating furnaces, in internal usages and power plant. The COG gas typically consists of 55% of hydrogen, 7% of CO, 25% methane, small amounts of CO2. And today mostly COG is mostly used for heating purposes, and we are not utilizing its potential as a reducing agent. So we propose to utilize this, since it has 55% of hydrogen, utilize the COG gas for reduction in the blast furnace. The process for this is a very simple process. So as you can see, we only need a compressor and the treatment plant if required, depending on the gas condition of the individual plants. So one compressor unit, and it compresses the COG gas, takes to the distribution, and it is distributed to the blow pipes or through the towers. So in this setup, we are not disturbing anything in the existing furnace setup. It is a standalone system. The installation itself can be done standalone, and you don't need big shutdowns for installation of the system. The benefits which we get, so it reduces the gas amount in the furnace, helps in production increase. It also increases the hydrogen content in the boss gas.
Please sum up quickly.
Yeah. I will just go to the next. These are the advantages of COG injection. It is in-house available, so we don't have to depend on anyone else for the gas. Then it gives you a coke saving of around 0.5 to 0.8 kg, and it is the reference. We have references of the plants operating with these conditions. And why Bolwath SMS? Because we have a long experience in injection technology worldwide, and for different like we say oil, tar, natural gas. These are our references, and the top 5 are already installed and working, and we are happy to inform that we are also working in India with Tata, Miramanli BF1 for own gas injection. The project is under engineering stage. So yeah, very quick, let me just take 5 minutes. Yeah. If you can see
please sum up quickly. No 5 minutes.
The status quo, what we are showing is status quo, and then we are showing blue blast furnace, and then the next process, easy melt. When you say blue blast furnace, this is step 1. So what we are proposing is, we are proposing shaft injection of syngases in blast furnace. This syngas which will utilize natural gas and coke gas, natural gas, coke gas, gas available in the plant, used through a reformer, produce syngas, and will be injected into the furnace. This process can reduce the CO2 emission by 28%. If hydrogen is available, it can directly put into the reformer, and it can also be used, which also further helps for the reduction in CO2. In step 2, what we are proposing is easy melt. But when we call easy melt is electrically assisted melting. So what we are doing is we are producing syngas. We are removing the blast from the furnace. So that is why we are not calling it as blast furnace. We are calling it easy melt. So what we will do is we will produce syngas, heat this syngas initially using oxygen, more of oxygen. So we call it oxymelt, and then subsequently using electrical plasma heating. And so the name easy melt. So we will inject the syngas at around 2200 degrees Celsius into the furnace, and parallelly injection will happen on the shaft also. And this process aims for a coke rate of 100 to 180.
Thank you, Mr. Prashant. Thank you very much. I'm very sorry because I have to abruptly close it.
Yeah. Okay.
I'm very sorry about that. We did have a very good session of 6 presentations. At least with this presentation, I can rest assured that my job is still there, because since morning we were hearing about DRI route, EA route, but still with his presentation, sinter plant and blast furnace is going to remain there for coming times, and with efficient operation, we can still do better. So thank you, Mr. Avinav Prashan. And as I said, we did have 6 presentations in this session. Just to quickly sum it up, I'll request our session chairman, Mr. Ashwini Kumar, to kindly do the honor of summing it up.
नमस्कार सबको। ये मेरा फोटे नहीं है एक्चुअली इस टाइप का जॉब के लिए, इज नॉट माय फोटे, but still I will try. There have been 6 presentations. First was from Mr. Nahar, APL Apollo Building product. They are mainly in the infrastructure field, and they have Mr. Nahar has given a elaborate presentation. As far as decarbonization and carbon footprint etc. is concerned, their job is very obvious, what they were projecting also. Use of less steel for the same purpose. High strength steel and also the design, innovative design so that less steel is used for any structure or any infrastructure, whether it is a building or whatever. Their role is very important, and what they were projecting, they are doing a good job, it seems. One way of decarbonization is, everybody was telling that we have to develop lighter steel, high strength steel, and Mr. Nahar is on the way in that direction. Next presentation was by Mr. Bhushan, very interesting. Mainly he was concentrating upon 3 products, process improvement products in sinter plant, pelletization, and third was coke making. And they claimed that coke rate will be reduced by 20 kg per ton of hot metal if you use these 3 products in our steel making, iron making process. I don't know how effective it is. The blast furnace people may talk to them, but one thing is sure that it has to be cost effective. How techno-economically it is viable, that has to be seen, and they may explain how it is viable. So blast furnace people may talk to them, but this is a very significant product, it seems. 20 kg per ton of steel coke rate reduction is quite appreciable one. And certainly, if we use less coke, we get less coke rate, decarbonization is the main issue, and that is bound to happen. Then third was from JSW Steel, Mr. Balchandani. They projected how they have been doing in the field of decarbonization and to reducing carbon footprint. They have initiated so many things in their plant, and in future also they are taking up so many things they have projected. And it's a big claim that 15 million ton of CO2 reduction by 2030, what they claim as. So it's a very, very, very appreciable what they are doing. JSW is certainly one of the pioneer of steel making and one of the highest capacity steel maker. So if they come forward and guide the other smaller people, people can take clues from them, and they can do in the same field for reducing this carbon footprint and decarbonization. The next 3 presentations were from the main among the topmost equipment and technology suppliers. Actually, they are the persons who can lead us steel makers in the direction of decarbonization and reducing carbon footprint. But because any steel plant, whatever they do, ultimately they look for technology suppliers, look to them, and equipment suppliers, how technology can be developed to reduce the carbon footprint, decarbonization. 3 presentations were made. One was Mr. Joel from Danieli. they projected this high strength rails, high speed, high strength rails and wear resistant rails. I am not a person from mill or rail mill, but rail mill person from Billai or maybe from, if there are people from JSPL, they may discuss with them. Already Billai is trying, Billai is doing the high speed rails and wear resistant rails. How this product, what they have suggested, can better our rail product, it can be discussed. Then Mr. Ganguly from Prime Metal, the Arvedi ESP process. It seems it is one step ahead of thin slab caster. Is it so? Something like that can trust hot roll product. But how it is better and how much it is better than that, that has to that they have to explain. They have to comparatively, they have to explain the people how it is better than that. So, but it is a well-known fact that this sort of technology consumes lot less energy, and certainly use of lesser energy is certainly going to help decarbonization. Then last one was Mr. Prasun from SMS. Mainly they have concentrated on blast furnace, process development and use of some very innovative ideas, coke oven gas injection and some easy melt or something. So this is a new thing for me, at least for me. I am not a blast furnace man, but still I am aware of certain blast furnace process. This is certainly new thing, coke oven gas injection, and how it is going to help, how it can be incorporated in existing blast furnaces, whether some capex investment is required or in existing they can use it, and how much it is going to help. The claim is 6% reduction in CO2 generation. If that is so, then it appears to be quite useful. So overall, all the 6 presentations were to certain extent different and very, very effective, and people can, there was no question answer session. People were curious about certain things, about all the presentations, but time was short, so they can discuss it during lunchtime or even beyond that, or they can, as Mr. Datta was telling, they can put their question on paper, which can be replied in writing form also. So thank you all the presenters, thank you Anup. It was a nice session, and I thanks the organizers to invite me for this session. Thank you.
Thank you very much, sir. Our heartfelt gratitude to you for subbing this presentation in such a short span of time. I would also like to thank each one of the presenters for making their presentation smart, informative, and we very much appreciate the way they accommodated it within a span of 8 minutes, which was announced in the 11th hour. I now request the session chairman, Shri Ashwini Kumar sir, to kindly present a memento as a token of appreciation to each one of the presenters. I call upon Mr. Brajesh Nair, CEO, APL Apollo Building Products Private Limited. Please give them a big hand. Mr. A.V. Bhushan, Director R&D Innovation, Avitech Energycon Limited. Mr. Badal Balchandani, Assistant Vice President Sustainability, JSW Steel Limited. Mr. Kaushik Ganguly, Assistant Vice President Technical Sales. Mr. Nishant GR, Assistant General Manager Sales, Denali, India. Mr. Mr. Abhinav Prasun, SMS India Private Limited. Thank you very much, sir. I now request CGM Central Plant, Shri Anup Datta sir, to please present a memento to Ashwini Kumar sir, ex-CEO RSP Sale. Thank you very much, sir. I now request CGM PPC Shri Tushankar sir to please take the dais and present a memento to Shri Anup Datta sir, CGM Central Plant.
Don't forget to like, subscribe and share the videos.